Hello everyone, so today we'll be solving swim in rising water and this is day 20 of June Lead Code Challenge. So the question goes like this: on an n into n grid, each square, that is grid of ij, represent the elevation at that point ij. Okay, so now rain start to fall and at time t the depth of the water everywhere is t. Nice. Okay, so you can swim from square to another four directionally adjacent square, so we can go anywhere now, if and only if the elevation of both sides individually are at most t. Okay, you can swim infinite distance in zero time. Of course you must stay within the boundaries of the grid during the swim. You can start from the top left square 0 0. What is the least time until you can reach the bottom right? Okay, so we need to traverse from 0 comma 0 to n minus 1 comma n minus 1, and we want to say what is the least time we need to find out. So the question is little bit confusing, and if you don't get what the question is asking, so basically there are different time values. So let's say these are x, and we need to find such x for which we can travel from top to bottom such that the maximum value in that path is less than equal to x. So let's understand it with example. So let's say this 0 comma 2 and 1 comma 3 is the first example. So let's say 0 comma 3, and let's write in the matrix form 0 comma 3 1 comma 2. So this is our first example. So you see we are it's I think 2 here and 3 here. Yeah, so in this example you see we are at the starting position 0 comma 0 and we need to reach this position at 3. So initially t was 0, so we cannot go to either right or either down, because it would have required 1t or 2t. Value of t should be 1 or 2. So for 0 value of t we cannot go anywhere from this position. So let's try for the 1t. So when t is equals to 1, I see I can go one step down, but after that I struck, because I cannot go right from 1 and I cannot go right from 0 also. So if you see, we need to take value of t as 2. So if we take the value of t as 2, then I can go down as well as I can go right. So first of all I will go down. Now my t value is 2. Is it greater than 1? Yeah, okay. So now I need to go right. Let's check whether the value of t is greater than 2. Yes, it is, but the value here is 3. So it is not possible to go from 1 to 3. Now let's come back and see for the 0 to path. So from 0 to 2 it is possible to go, since t is 2. Now 2 to 3 it is not possible, because in that path the maximum value is 3 and the value of t we have is that 2. So here we need to take the value of t as 3, and then only we could reach this last index. So let's see the language. At time 0 you are in the grid location 0 0. Okay, you cannot go anywhere else because four directionally adjacent neighbors have higher elevation than at t equals to 0. So the elevation of the neighbor was 2 and here it was 1, and we had value of t as 0. So you cannot reach 1 comma 1 until the time is 3, because at time 3 we would only be able to get to this bottom point. So when the depth of water is 3, we can swim inside the grid. Now let's take this example 2 and actually understand how this is working. So I will remove that, and okay, so this is our example 2, and now you see let me indent them properly. Now you see we need to find the minimum value of t for which we can have a path such that we can traverse from 0 0 to n minus 1 comma n minus 1. So if you see, the path that was described is in the dark. So we go from 0 1 2 3 4 then 5, and after 5 we go to 16 15 14 13 12, then 11 10 9 8 7 6. So one thing is quite clear, that we cannot use dp here, because when we had the question of dynamic programming, for element we would have the condition that either I can come from the top or either I can come from the left side. So for say if this was only constraint that I can move right or I can go down, then for easily 18 I would have say that either I can came from 14 or either I can come from 17. So I would check these two cases and I would say that whatever the maximum value is, that is the maximum value we would require for the t for reaching this 18 position. But here is not the case, we can come from any position from any side, so we need to go for DFS first of all. That is the quite clear observation. And second thing is that we are given the constraint that grid of ij is the permutation of 0 to n minus 1, sorry, 0 to n into n minus 1. So we know that every element of this grid is a combination of starting from 0 to maximum value of n into n minus 1. So what we can do is that, or what we have to do is that, we have to go from 0 to n into n minus 1 minus n into n minus 1, and for every value of this we need to check whether it is possible to find a path in the grid such that we can go from top to bottom. So I hope question must be clear and what we need to do is clear. Let me repeat it once again. From 0 to n into n minus 1, we need to find a path in the grid. So let's say, let's take this example itself. So in this second example, we had our n was 1 2 3 4 5, so 5 was the n. So initial value can be 0, and 5 into 5, that is 25 minus 1, so 24. So from 0 to 24 we need to find a value such that this value satisfy a path from top to bottom, and this value is greater than every element in that path. So let's say, for the sake of example, if I say I take 12 value, so let's see whether it is possible to make a path from this 12 value. So I can, from 0 I can go to right only because 24 is greater, so I will go to right. I will go to 1. From 1 I only go to 2 because I cannot get to 23 because 23 is greater than 12. Then from 2 I will go to 3 only because there is no path other than that. From 3 to 4, 4 to 5, and 5. After 5 I would have get stuck because if I go to any other place from this 5, I need to go with the value greater than minimum 16, because you see here 16 is and here is 21, so 12 is less than both of them, so 12 is not a possible answer for this. So if our DFS is stopped for a particular value, then we know that it is not possible to make a path from it. So in this case the answer is like 16 itself, because 16 is the barrier point. So if, let's see, if we take a value of 16, so you go from 0 1 2 3 4 5, and after 5 I would go to 16, and you see in path from 16 15 14 13 12 11 10, then 9 8 7 6, the maximum value we found was 16. So it was even possible, it was possible to have a path with value 16 as the highest value in that path. So I hope this this sounds logical and the explanation is clear to you. So let me repeat again. What we will do is that we will find a value from 0 to n into n minus 1 such that this value satisfy a path in the grid for which every value in the path is less than this value. Now after thinking about this, we need to check, since these values we are checking from 0 to 24, so what we can do, we can use binary search to do that. So if you use binary search for this, then this would be log of n, and for DFS we would have n square for each DFS call. So our time complexity will become big O of n square into log of n. So let's try to code it out and see how we can code this solution for this problem. So I hope the approach and the intuition must be clear now. So let's code this out. So initially I will take my grid size, so it is n equals to grid dot size, and then I need to do binary search. So my low will be 0 and my high is this is n into n minus 1, and I have to also take a mid value, so this is mid. So while my low is less than high, what I will do, I will say my mid is low plus high minus low. It is high minus low divided by 2. So I got my mid. Now I will check if DFS of this call for grid with value mid. So I will check whether it is possible to reach to the bottom with this mid value as my T value. So if it is possible, then I can say I need to say high is mid, and if it's not, okay, this semicolon is missing here, else we will say my low is mid plus 1. This is simple binary search. You can visit binary search if you have struggled with this, and simply we will return low. So the simple part was it, and now we need to define our DFS function. So one thing I would like to change here is, and let's not name it as DFS because it is not a good naming convention. Instead of that, we can use swim in water helper. That sounds good, and this is actually a good convention. So let's use this only. So it will be a bool type. So first of all, we will take a vector of integer. It is a vector of integer. So it will be grid. Now I need my mid, which is int t, if you see according to the problem statement. Now I need a visited array. So what I will do is that I will create a visited array. So let's say vector of boolean, and it will be visited. It will be of size n into n, which is vector of int n, and initially I will initialize everything to false. So this is false, and I need to pass in here. So this is visited. Also I need to pass the starting positions, which are 0, 0, because we want to start from the 0, 0 position and travel to the bottom n minus 1 into n minus 1. So here we will take our visited, so it will be bool. I think I also made mistake here. It is bool, and let's pass this by reference. So visited, after this we need to say int I, which is my I index, and j index, and also let's pass n to check the base case. So let's take it in here, int n. So I think that's enough. This is all we need, and now we need to say, so if my I is equal to n and j is equal to n, that means I was at the last index, and it was indeed possible to find a path such that I can traverse from 0, 0 to n minus 1, so I will return true from here. Otherwise, what I will do, first of all, I will mark this ij index as visited. So visited of I and j, I will say it is true. I have visited this index, these indices, or whatever you say. So now I need to go in every 4 direction. So one better way of doing this is, let's define a vector of positions. Let's name that int, and it is, so let's take 0, 1, then 0, minus 1, and then 1, 0, let's say, and minus 1, 0. So I will take all these indices, and so let's say int I, let's say p for position, p equals to 0, p less than pos dot size, and p plus plus. Okay, so after this we need to find the indices which we need to calculate. So int x, which is the new I index, is earlier plus pos of p0, and here int y will be j plus pos of p, 1. So it will give me all the 4 indices. So one by one x and y value will take all the 4 adjacent values of I and j. You can check that out, and after that I need to check condition if this x is greater than equal to 0, and then this x is less than n, and this y is greater than equal to 0, and this y is also less than n, and these indices are not yet visited. So if these are not visited, x and y, and then the main condition we need to check here is that this grid of ij, which is the value of particular ij in my path, should be less than and equal to this t. So here you see it is the main condition. So let's say here if we had 16, so I need to check whether 2 is less than 16, whether 3 is less than 16, whether 5 is less than 16. So for every I and j index we will need to see, and if all these conditions satisfy, then I know, then I can go forward from here, and I can traverse all the path from here which are not yet visited. So we will say if we will visit this swim in water, uh, let's say, so we will visit this helper function. Now this time grid will be same, my t will be same, and visited will also be same. Now int become I become x and j becomes y, and n remains same. And if this helper returns me a true, so if this is true, then I know it was possible to go to that path, so return true from here. And if it is not the case, then finally we will return false from here. This false means that for all the position we tried, but it was not possible to build up solution from there, hence we return a false. So this is quite it, I think. Now one thing we need to do is we need to say this vector should be different for visited vector should be different for every call. So we need to do it here, and let's see if there's some typo or some error here. So okay, this is equals to, and I think we are good to go here. We need to check for n minus 1, I guess. Yes, it is n minus 1, because if we are checking for, so here if we are calling this function, then it means that for okay, it's x and y. Too many errors at this time. So we need to, if we are checking for x and y, we know that if this function was called, then we have checked the value that grid of x and y is less than t. So if for I and j, which are both n minus 1 and n minus 1, the value is checked, so we can simply return true from here. So let's see whether this works or not. So let's see whether this works or not. So it's compilation error. Okay, it is vector of vector. Where is it? Line 7. It is vector of vector int. Okay. It is now okay. So yeah, this is working this time, and let's submit it. Okay, wrong answer. Okay, so this grid needs to change from 0 0. It is not always given that grid should start from this position. Now let's try to run this. It's grid. Okay, so its low should be grid of 0 0. It not guarantee that it is a start from 0 0 every time. So let's see now whether this runs or not. Yeah, this time it worked, so let's submit it. Okay, is it accepted? So thank you everyone, this was it for today. This was swimming the rising water. Have a good day.